Namaskara. In this video, I'll give you an introduction to three electronic tools, namely Multimeter, Oscilloscope and OBD2 Scanner.
12 seconds later.
First, let me introduce you to multimeter. This is one of the fundamental tools in the field of electronics. By using this tool, you can measure many parameters such as voltage, current, resistance, capacitance, frequency, temperature and other parameters. Basically, the multimeter is primarily used for voltage and current measurements. This first mode is for voltage measurements, and you can see the blinking LEDs, right? One important thing you need to keep in mind is voltages in the circuit are measured in parallel fashion, that is across the components. Current is measured in series. Here in this voltage we can either measure DC voltage or AC voltage. In this function button I can switch between AC voltage and DC voltage. DC is direct current and AC is alternating current. Usually you can find this AC in our wall sockets. That is, usually in India it is 220 volts and in American homes it is 110 volts. DC voltages you can observe in batteries or portable electronics such as in our mobile phones or laptop batteries, or even the battery that is powering this multimeter is in DC. And the next one is millivolt measurements. When we are measuring very low voltages, this will help in getting accurate measurements such as 20 milli or 30 milli or 80 millivolts. The next one is frequency measurements. Usually in AC voltages or analog voltages, the voltage will keep on fluctuating, that is on off condition, or from positive to 0 to negative. In those signals we can measure frequency. And the next one is resistance measurements. In this resistance measurements, we can start from 0 or 1 ohm up to few mega ohms. In few multimeters, there will be a set of range for resistance such as 0 to 200 ohms is one setting, from 200 to 5k is one setting, from 5k to 1 mega is one more settings. Or you can have a auto ranging multimeter which has full resistance scale in single settings. In the same setting, we can measure the continuity of the wire, that is, it usually beeps which indicates a wire continuity is proper, and there is a mode to check the diodes as well. This mode is used to check the capacitors, usually to measure capacitance value. And this one is to measure temperature in Celsius or Fahrenheit. Manufacturer provides a separate probes which needs to be connected here. And now we come to ampere, that is current measurement. Current measurement, as I told earlier, we do it in series fashion. That's why when I put it here in amps, it is showing a different LEDs. That is, for voltage it was showing here, for current it is showing here. That is, we have to switch red probe from voltage measurement to current measurement, and the common or black probe will be here itself. And this one is to measure the current up to 10 amps. And this is milliamps measurements, this is microamps measurements. Along with this, we can even measure frequency of AC current. This one is non-contact voltage measurement, that is, it has an antenna here which can detect live or neutral wires of the AC socket. And one more important thing we need to keep in mind, there is always minimum and maximum ratings in the multimeter. That is, when it comes to DC voltages, we have maximum limit of 1000 volts. And for AC voltages, we have maximum limit of 750 volts. In current, we can go up to 10 amps in this socket, and here it is milliamps, that is limited to 600 milliamps. And if we exceed these ratings, there will be fuse provided inside, it will blow up and we need to replace it. That's why it is better to stay within these limits. Now I will take oscilloscope. That is, I have PC based oscilloscope, that is PicoScope Series 2000, the model is 2204A. This is a 2-channel oscilloscope, and if we see the specifications, the resolution is 8 bits at 100 megasamples per second, and the bandwidth is 10 megahertz, and it has a storage capacity of 8 kilosamples. To use this oscilloscope, we need to connect it with the PC or laptop using a USB cable. And Pico technology provides a software along with this device through which we can see our measurements and record measurements or use it for special functions. Now this is the probe that is provided with the PicoScope. It has two ways of measurements. First one is like this, a hook kind of structure which is helpful in connecting to wires, and another way is this one. You can use this for measurements. Now I will measure the noise and show you the waveforms in the laptop. I have connected this PicoScope to the laptop using USB cable and the probe goes here. I am using the channel A for this demonstration. In this software you can configure many things such as probe settings or attenuator settings and scope settings. You can do probe settings here. You have option of selecting voltage ranges, coupling mode and other things, and we have an option of setting sample rate, that is number of samples per second. We have either increase it or decrease it depending upon the application. And one more setting is this lines you are seeing on the graph, right? This is number of samples per division. This also we can increase or decrease depending upon our application. And there are options to set trigger as well. I'll be explaining these features in future videos. Let me start capturing. Now let me give noise to this probe. Here you can observe a sinusoidal wave, right? See? Now I am increasing and decreasing the number of division, that is now I am increasing. So you can see real time how it is changing. Here if you observe, the counter is going up, right? This is the storage that I was talking about earlier. That is, it can save up to 8 kilo samples, and you can pause this, go back in time and observe your waveforms. In this software we have additional functions such as we can do calculations, measurements, we can even do serial decoding of many protocols such as I2C, UART, CAN bus, LIN bus and many more. I will be giving a practical demo of this using a CMP sensor on a car that will give you a clear picture. Now let me introduce you to third tool, that is OBD2 Scanner. OBD stands for Onboard Diagnostics. Here I have taken ELM327 as an example. Using this tool, we can read fault codes present in the different systems of the car. That is, either it can be fault codes present in the ECM or BCM or airbag or ABS modules. If you remember, in each videos I used to explain malfunction indication lamp comes on and it will have permanent codes and temporary codes. All those things we can read using this tool. Usually it contains a standard 16-pin OBD port. What I have is an affordable OBD2 scanner. There are advanced scanners or company specific scanners which have bi-directional control. That is, you can even send commands from this scanner to the control systems of your car to do certain tasks, such as you can control your fuel pumps, you can control lighting systems. That is, you can actuate things and see if they are working or not, or you can read raw data from the sensors. Here I am using torque app. In this you can see I have many dials. Each of it gives a different parameter, such as this is speed, this is RPM, this is ignition timings, this is load. So different dials will give you a different information, and we can use this scanner to clear the fault codes as well. That is, after fixing a particular issue, we can delete those stored codes, and then only MIL lamp on your dashboard goes away. Here I have only briefly explained these tools. In the future videos I will take each tool and explain you in detail with the practical demo. If you found this video to be informative, please do like, subscribe. I will meet you in the next video. Bye bye.